thing is going to be covering linear programming. I want to apologize first of all for the blurry text, but this is a problem in your homework. If you'll look in your homework from Friday, you should see this one. I believe it's the very last one, the first or second page. A company manufactures inkjet and laserjet printers. They can only make 60 printers a day, and it has a possibility of using 120 hours to create these printers. It takes 1 hour to make an inkjet. It takes 3 hours to make a laser. The profit for each one, they're going to make $45 per inkjet printer, and they're going to make $65 for each laser printer. The main question that we want to answer today is how many of each printer should the company make if they're going to maximize their daily profit. So if they could sell every printer that they created, what's the best case scenario? What should I make of each one so that I could make the most and sell the most printers in one day? Well, okay, there's a couple of things we need to go over. First of all, and this should be your first step, define your variables. Define what x is going to be, define what y is going to be. So we're going to look at it this way. We're going to say we're going to let x be the inkjet, and we're going to let my y be the laser printer. Now, if you go back up to the top, if you look up here in the problem, we're going to kind of look through this and write down the different quantities, the variables that they're going to be discussing. Basically, what numbers did they give me to work with? It's going to be describing something. So if we look at the first set of numbers, they tell us each day the company can make only a maximum of 60 printers. So if I took the number of laser and the number of inkjet, then if I added those together, that would tell me exactly how many I'm going to be making in one day. So when I say x plus y, I should tell that can be no more than 60. So if I added the number together, and you can see that in the first inequality you have at the bottom, if I add those two things together, I can't ever have any more than just 60 printers created in just one day. So that's the first thing you tell us. The second thing is about hours, number of hours each day. It's how many hours can we distribute between the two different printers? Well, it tells us here's hours, and here's another description for hours, and a third description for hours. What we're going to look at, we're going to make an equation that pulls together all three numbers for hours. Well, this is talking about inkjets. That's x. And this is your laser. It takes 3 hours to make a laser printer, but I can only have 120 hours total. So if I multiply the number of hours for each one times 1 and then times 3, they can't add up to be more than 120. And so at most, as we said in class, the key phrase at most is always less than or equal to. And you can see that here in the second equation. If I add x plus 3y, that's got to be less than or equal to 120. If I don't do that, then I'm not going to have enough hours in the day to make a specific number of printers. So the last part that they talk about is profit. They tell me they're making $45 per inkjet and $65 per laser. Well, if I take the number of laser and the number of inkjet, that's what x and what y represent, 45 times the x's and then 65 times the y's, that's going to tell me how much I'm going to make on profit for each type of laser. And if I add them together, that's going to tell me my total profit. Now this is kind of what we talk about our overall equation. This is what we're going to end up plugging our values into, because that's really the last question. How can I maximize this equation? And so I'm going to look at my graph once we get it shaded, and I'm going to decide what numbers to plug into this equation. There's two other things I'd like to talk about, type of equations. You can see here that x is greater than or equal to 0, and y is also greater than or equal to 0, because these equations basically say you can't make negative printers. I can make none of them, or I can make more positive values of them, and that just makes perfect sense. What we want to do is we're going to we're going to graph each of these equations, all 4 of them. Now the first thing we did before we graphed them is set the first 2 equal to y. And so, and you'll see that in just a second. Make sure that you do that because it will be difficult to graph it this way. So we're going to go over to this program and we're going to look at the graphs. So you can see up here I've solved each one for y. So you have y equals negative x plus 60. You have the next one, which is negative 1/3 x plus 40. And then, of course, my y is greater than or equals 0 and x is greater than or equals 0. Let's start out going from bottom to top. So if I graph y is, or x is greater than or equal to 0, that's obviously on the right side of the y-axis. The positive x-axis is going to be covered. If I go ahead and shade in the y is greater than or equal to 0, then we have the top covered above the x-axis, and you can see here that you have green on the top and you have orange at the bottom, so they overlap only in the first quadrant, which is kind of, you've seen that occurring most of our equations. Let's graph this one. We have 1/3 x plus 40, and so you can see here it starts at 40. These go up by 5s if you can't tell, and so it passes through at 40 and travels down at 1/3 slope all the way down. It is a negative slope, so you can see that. Let's go ahead and finish it off. And you can see that this one's going to go through 60. Here's 50, 55, and 60. It has a slope of -1, so down 1 over 1, down 1 over 1, down 1 over 1. And you can see how it just keeps on going down to hit 0 or 60, 0. And you can see our little quadrilateral here. It starts here, it goes down to 0, 0, it goes over to 0, 60, 0, and it goes up here. Now, if you did this by hand, and I suggest that you go back and try this problem without looking at the notes, without looking at the tutorial, and you can see here that if you use your slope on this one, you go down 1 over 1, you go down 1 over 1, you're going to eventually find that exact point. Also, if I go down 1 and over 1, 2, remember these going by 5s, so I'll actually hit that point also. So if you're doing a good job graphing your lines, you're going to actually find this exact value by using your coordinates and by using your graphing techniques. And so here you have your little quadrilateral shading. What we want to do is we want to write each of these coordinates down, and we're going to plug each of those values into our equation. So let's go back to our other sheet and let's look at it. And so what I've got here is I've already labeled, it's the same exact image, but I've zoomed in a little bit, clarified a few things, and we can see our shape. I've outlined that in black. These are the points that I want to try to plug into my equation. So we're going to go down just a little bit. We're going to look at the equation I've already plugged in. Now notice I didn't plug in 0, 0. The question was to maximize information. We all know that 0, 0 is not going to be the max. So don't waste your time in trying to plug it in. So I plugged in 0, 40, I plugged in 30, 30, and 60, 0. Those were the 3 points that we saw up at the top for the other 3 coordinates. We plug them in, and you can see here as I work them out, and as most of you probably thought before we ever plugged them in, that 30, 30 was going to be the maximum value. Now don't just jump to that conclusion, because it doesn't always work out that way. A lot of the time it depends on what your equation was, what your profit equation is. So in this case, the answer to the question would be they should make 30 of each, 30 of the inkjet and 30 of the laser printer to maximize their profit. Make sure you check back over this. Try this by yourself and see if you can come to the same conclusion. If not, rewatch it. And if you have questions, bring them with you to class.